Hi, Algebra 1 students. I'm going to go over some of the homework problems that were due on May 6 and 7 on reviewing of factoring. For the first two problems, you were supposed to use the greatest common factor. So look for the greatest common factor in each one. If you take a look at this problem right here, it has three terms, and I notice that each term has a coefficient that's a multiple of 3. So 3 is going to be the numerical part of the greatest common factor. Then I look at the variables. Every single term has x and y. So I know I'm going to have an x and a y as my greatest common factor also. So my greatest common factor is going to involve 3x and y. Now I have to find out x to what degree, to what exponent. And to do that, let's look at all the exponents on x's. There's an exponent of 2, an exponent of 3, and there's not one here, so it's understood to be 1. X to the 1 is x. So the lowest number, exponent, that's what I want. And the lowest number is x, so I pull the x out. So it's 3x to the 1. And for all the y variables, the exponents are 1, 4, and 1. The lowest exponent is 1. So I just pull out y to the 1, or just y. I don't have to write y to the 1. So I put my greatest common factor in front of a set of parentheses to show that I'm going to multiply that by 3 terms to get these 3 terms. And then I have to figure out what am I going to multiply 3xy by to get 6x squared y. Well, I know the coefficient has to be a 2 because 3 times 2 would give me this coefficient of 6. And then I have to ask myself, x times what would give me x squared? Well, that's going to be x times itself will give me x squared. And then y times what is going to give me y? Well, that's going to be 1. Y times 1 is y. So it's really 2x times 1, but I don't need to put the 1 there because anything times 1 is just itself. So I leave it as 2x. Now let's go to the second term. 3xy multiplied by what will give me 9x cubed y to the 4th? Well, it's going to have to be a coefficient of 3 because 3 times 3 would give me the coefficient 9. X times what is x cubed? So to do that, I can do x cubed divided by x, or I can think x times what is x cubed. Well, I have to multiply x times itself 3 times here, but I only have 1 time here, so I need to multiply x by itself 2 more times here. X times x would give me x cubed, so I know it's going to be x squared here for my second term. And y times what would give me y to the 4th? Well, over here, y is getting multiplied by itself 4 times, so I need to think to myself, y times what gives me y multiplied by itself 4 times? I need y multiplied by itself 3 more times. Y times y cubed would give me y to the 4th. And then my last term, 3xy times what term is going to give me my last term here? Negative 3xy. Well, the only thing I need to do is change the sign. 3xy times negative 1 would give me negative 3xy. The same principle applies here. I'm not going to go through it, but you can see the answer, okay? When you get to the rest of the problems, you had to factor the trinomials by looking for 2 binomials, 2 term expressions in parentheses getting multiplied together to get here. So you're unfoiling. I need to figure out what's getting foiled here. When the leading coefficient is 1, like they are with numbers 3 and 4, what do I mean by that? The highest degree term here is 2, b squared, and the coefficient of the squared term is 1. The coefficient of the highest degree term, c squared, is 1. These are the easy ones. This is where you just set up your parentheses. If the first term is just b squared or c squared, I know I'm going to b in both sets of parentheses here as my first term, because b times itself would give me b squared. Then I look at the constant term. This is the key to it all. Look at the constant term and look for factors of positive 10 that when I add them together, I get negative 7. So 2 numbers multiplied give me a positive 10. I know they're going to both be positive numbers or both negative numbers to get positive 10 when you multiply them. I look at the sign of the middle term. It's negative. So I know I'm going to have 2 negative terms. So it's going to be b minus something, b minus something else. The factors of 10 are 1 and 10 are 2 and 5. But negative 1 times negative 10 adds up to negative 11, not negative 7. But negative 5 times negative 2 will give me the positive 10, last constant term. But negative 5 plus negative 2 will give me the outer and inner terms that add up to negative 7b. So I need to find two numbers that multiply to positive 10 but add to negative 7. They multiply together to give me positive 10 but add up to negative 7. Okay? The same principle applies here. I'm not going to go through it. The only one thing here is that my constant term is a negative number. So I know I'm going to have c plus something and c minus something. And you can just check. For numbers 5 and 6, I originally had the wrong answers I gave out to students yesterday. I don't know why. I just didn't have enough sleep. That's my story, and I'm sticking to it. But the answers are correct now. For number 5, I just do guess and check. For right now, there's another method. We haven't taught it to you yet. There's a more thorough method. It involves a lot of steps, but there's a sure way to get it too. But when the leading coefficient is prime and the constant term is prime, there's really no need to go through that long, methodic method. So just set up your two sets of parentheses first, empty parentheses. To get 3x squared as my leading term, I'm going to have 3x and x. It's a prime number. There's no other way to do it. 3x times x will give you the 3x squared. I looked for the sign of my constant term. It's positive. So I know I'm going to have either 3x minus something and x minus something, or 3x plus something and x plus something. They're going to have the same sign. And I look to the linear term, the x term, to see what sign it'll have. So I know I'm going to have 3x minus something. I know they're going to be both negatives. 3x minus something, x minus something. Let's look for factors of 2. It's prime also. There's only two numbers that multiply to give us 2, 2 and 1. So it's either going to be the 2 here and the 1 here, or the 1 here and the 2 here. Lucky for me, the first thing I tried worked. I put the 2 here first and the 1 here first. I kind of knew. I was looking ahead. Well, I knew I'd get, if I was here, I'd have minus 3x, and here would be minus 2x. If I had swapped this 1 and 2, this would be 3x times negative 2, which would be negative 6x. And the inner term would be negative 1 times x would be negative 1x. And negative 6x and negative 1x add up to negative 7x, not negative 5. So this is the correct answer. Number 6, this was a little trickier because the first term here, the leading term, had a coefficient of 4. There's two ways to get 4x squared. I can do 4x times x, or I can do 2x times 2x. I tried 4x times x first. And I just guess and checked. I know my constant term is positive, so I'm going to have either negative, negative, or positive, positive. The lead in this term is negative, so I know it's going to be two negatives. And I just tried 3 and 1, and when I checked it, it didn't work. So I said, nope, doesn't work, cross it off. I don't like to erase the answers that don't work because sometimes I mistakenly try them again, not knowing I already did that. So I keep a record of my wrongs. It doesn't work, cross it out. I can still see it though, so I can still see not to try that again. And then I just tried swapping the 1 and the 3, and that didn't work either. Didn't get negative 4x. So I said, okay, let's try 2x and 2x. 2x minus 3 and 2x minus 1. It didn't work. It gave me, a linear term of negative 8x. So I said, okay, let's swap the 3 and 1 and try 1 here and 3 here. And actually, it's the same thing. It doesn't matter if I swap it around. I didn't really need to try it again, but I did. And I still get negative 8x. In fact, this isn't factorable. So this was kind of a stump. If you were stumped, there was a reason for it. Hopefully that helped you.